Question you see for a parallel reactions of second order with respect to two reactants with two reactor A and B giving C and D, first order with respect to A as well as B. This is a given, derive a relationship between rate constant, concentration, time, and initial concentration of A and B are given, A moles per liter and B moles per liter respectively. X moles per liter of C and D formed after time t. You know, after time t only you have to determine the rate. Okay, now in this question you see A plus B gives C plus D simultaneously, rate constant K1, its rate constant K2. Initial concentration given A moles per liter. So when time t equals to 0, its concentration is A moles per liter, it's B moles per liter. Its concentration 0, its concentration of 0 moles per liter. So initially it is not formed. After time t, you see X moles per liter of product form. That means X moles per liter C form as well as D form. Remember, but the yield of C and D is not same. Yield will be depending on the value of K1 and K2. This is the main tricks in parallel reactions. Now here after time t, A minus X moles per liter will be remaining. Here it will be B minus X moles per liter will be remaining, and X moles per liter of C form and X moles per liter of D formed. Now, what is the rate of this reaction? Because we have to determine the relationship between rate constants, concentration, time, and concentration of A and B, etc. will be involved in that derived equation. Okay. Now, what is the overall rate? Rate is equals to, in terms of X we can write dx dt, because X moles per liter of product form is directly proportional to concentration of A to the power 1 and B to the power 1, because it is given second order, first order with respect to A as well as first order with respect to B. So here dx dt is equals to, remember, K1 into A minus X into B minus X, because it will depend on this as well as this, plus concentration of, and what is the rate for the formation of C D, it will be K2 into A minus X into B minus X. Already you have derived in second order parallel reaction containing one reactant, same way, but here two reactants are involved. That is why both will be coming, because overall rate equal to rate of formation of C as well as rate of formation of D. Rate of formation of C will be this, rate of formation of D will be this. We have to add it. Now let us take common A minus X, B minus X. Here it will be K1 plus K2. Okay. Now we have to integrate now. Dx by A minus X into B minus X is equals to K1 plus K2 into dt. Okay, K1 plus K2. Now integrating both sides, K1 K2 constant will come out, plus it will come one integration constant will take. Now let me write it. Okay, it is a integration, but we have to do partial separation. In that way we have to solve this integration. The integration of A minus X into B minus X, we can write, you see, 1 by B minus A, we take common, and can I write 1 by A minus X minus 1 by B minus X. Dx, can we write? Because if we take LCM, A minus X into B minus X will be LCM, and B minus X minus A plus X cancel, it will become B minus A, and B minus A cancel. So ultimately this can be written in partial way. This way is equals to K1 plus K2 constant, integration of dt means T, plus integration constant I. Now 1 by B minus A integration. Now we can separate it. Dx by a minus x minus dx by b minus x is equals to k1 plus k2 into t plus I. Remember, same type of equation we got, but there only we got one rate constant. Here we will get two rate constant k1 k2, because parallelly two products are formed with rate constant k1 and k2. Clear? No. Now this integration we can make it standard integration. We know integration of dx by a minus x. Put a minus x equals to z t. Suppose in mathematics you did differentiating with respect to t. So dx dt equals to dt of t means 1 minus dx equals to dt. So it will be coming dt by t minus, that is minus ln t. It is minus ln a minus x. So this is the integration of this, and this is also standard. It will be minus ln b minus x. So let us see what will be the result. Finally, 1 by b minus a, it will be minus ln a minus x. Ln means log basic, that you know, plus minus a minus a plus ln b minus x is equals to k1 plus k2 into t plus I integration constant. So we can write 1 by b minus a ln a minus ln b, it will be ln a by b, so it will be ln b minus x by a minus x. k1 plus k2 into t plus I. Now this I value will determine, because we didn't take here in lower and upper limit. Let us consider, give one condition. When t equals to 0, x is equals to 0, at the commencement of reaction we know there is no product C and D from t equals to x equals to 0, and it will be value of I will be, this is 0, 1 by b minus a ln b by a, 1 by b minus a ln b by a, because x equals to 0. Now this value we will insert here and we will get the final equation, that is derived integrated rate law for a parallel second order reaction with respect to a and b, and first order with respect to a as well as first order with respect to b. Let's see what is the final derived integrated rate equation. So we'll put here I value. So 1 by b minus a, now very slowly you do now, ln b minus x by a minus x is equals to k1 plus k2 into t plus 1 by b minus a ln b by a. Okay, now k1 k2, let us take it here. So k1 plus k2 into t, I am writing this, is equals to this minus this, that is 1 by b minus a ln b minus, sorry, it is b minus x, b minus x by a minus x minus 1 by b minus a ln b by a. Just transfer on this side. Now here it will finally come out k1 plus k2 into t is equals to 1 by b minus a ln this minus this means ln this by the b minus x by a minus x by this b by a, so a will go up, a into b minus x and b into a minus x. So this is the final derived integrated rate law. So here we can write k1 plus k2. Instead of only one k, here two k's are coming, k1 k2, because simultaneously two products are formed, is equals to 1 by t into b minus a ln and log base c a into b minus x by b into a minus x. This is the integrated rate law for a second order parallel reaction, you need more than two reactants are involved. That means more than one reactant, and first order with respect to both the reactants. This is the final. Now this type of derivation they will not ask. This year one question was there. K1 and K2 was given in the question, and you have to find out the formation of C and D and what is the yield of C and D. This question was there. So this is the final derived integrated rate law. Now, okay, you make a note of it. Okay. Now you see on JEE Advanced or IT Advanced, they will not ask any this type of derivation. This year one question was there. K1 was given. In that question, it was given some P plus Q giving R and S. Here K1 and K2 given. K1 given, this value was 4.5 into 10 to the power minus 4 liter per mole per second, because it is a second order reaction, so its K value will be, we know, mole to the power minus 1 liter to the power 1 per second, that per minute, etc. So it is given like liter per mole per second. That is molarity in watts per second. And K2 was given 1.5 into 10 to the power minus 4 liter per mole per second. Same unit, same. Or the question was, what is the yield, percentage yield of R and S? It was a parallel reaction. In parallel reaction, we know K1 and K2, if it is given, how to get the percentage yield? The percentage yield of MCQ type question was there. Percentage yield of R is equals to K1 by summation of K, that is K1 plus K2 into 100. This percentage. Okay, K1 value is given, K2 value was also given, this one. So it will be K1 percentage yield of, the question was asked percentage yield of S. Its percentage yield you find out. So here percentage yield of R equals to K1 by summation of K. A percentage yield of S is equals to K2 by summation of K into 100, or 100 minus percentage yield of R. Very simple. The S directly we will calculate, no need to calculate R. Percentage yield of S equals to K2. K2 is given how much? K2 given 1.5. That is 1.5 into 10 to the minus 4 by summation of this plus this. That is 4.5 into 10 to the power minus 4 plus 1.5 into 10 to the power minus 4 into 100. Now so it is equals to 1.5 into 10 to the minus 4 by, you have 10 to the minus 4, you take common, 4.5 plus 1.5, that is 6 into 10 to the power minus 4, that is into 100, that is 1.5 by 4.5 plus 1.6, that is, it will be 15 by 60 into 100, that is 3 by 4, that is how much? 15 1 by 4, sorry, very simple, 1 by 4, that is 0.25 into 100, that is 25%. Sorry, 5 now, 15 15 by 60, that is 4, that 1 by 4, that is 0.25 into 100, that is 25%. So percentage yield of, the answer will be the percentage yield of the yield of S equals to 25%. Similarly, percentage yield percentage of R will be what? Definitely 75%. This question was there. They asked only percentage of S. Okay. So this type of question you might expect. One assignment I am giving, that the relation we have derived, you see, little bit trick I am mentioning over here. If this B is greater than A, if B is greater than A, then the rate constant K1 plus K2 will be equals to 1 by B minus A, because it should not be negative. The rate constant value should not be negative, into 1 by T it was there. If B greater than A, we got ln A into B minus X by what you got? Just you see B into A minus X. If B is greater than A, then the final expression will be like this, the integrated rate law of this parallel reactions containing two reactants A and B. Now, if A is greater than B, in that reaction you see A plus B giving C and D. Now, if E's concentration initial is greater than B, then you will do at home. What will be the final integrated rate law? It will be K1 plus K2. In that partial integration by partial fraction, there you will take common 1 by A minus B. If we take 1 by A minus B, then it will be what? 1 by B minus X, A minus X minus B minus X, remember. Because A minus X, B minus X, it was LCM, it will be B minus X and A minus X. That is A minus X minus B plus X. X cancel, A minus B will come. So ultimately the result will be here, it will be just opposite. In place of A, it will be B. So it will be K1 plus K2 equals to 1 by T. You will do that integration. This way you will take the common. A minus B you will take common. After that you will separate the fraction. 1 by T into 1 by A minus B. Okay. In this, if A concentration of A is greater than B, then ln, here it will be what? You will see, in detail you will do at home. B into A minus X by A into B minus X. This is also the integrated rate law for a second order parallel reaction containing two reactants A and B, first order with respect to A and first order with respect to B, and initial concentration of A and B are A and B respectively, small a and small b respectively. So this is your integrated rate law in case of A greater than B. This one already we have derived when B greater than A. Okay, but the question they will ask from K1, K2 percentage of formation of the product C, D or R is whatever abbreviation they will use. I think it is clear now. Consecutive reaction is not there in your JEE advanced. Although I have discussed some consecutive problems on consecutive reaction, that is little bit difficult. But parallel reaction is very simple reaction. Same type of equation you will get, but here instead of one rate constant, you will have two rate constant. Okay. If three products are there, then three rate constant will be involved. Parallel reaction containing three reactants, K1, K2, K3. So that way it can be elaborated, but that detail no need to discuss over here. Because in advanced tricky question they will ask. Very simple but tricky. These tricks you remember how to calculate percentage yield of different products in parallel reactions. Okay, next question.